our most anticipated sessions of each of these webinars. And so, Terry, I'm going to turn things over to you to give your presentation. Just let me know when you'd like me to advance the slides.
Thanks, John. How are we doing on time?
You're good. You've got about 25 minutes for presentation and questions.
Okay, very good. Well, let's roll on to the next slide here then. We're going to talk a little bit about vanadium market fundamentals and see if we can't lay a little groundwork for understanding what's going on and what may be next in this market. Next slide, please. So first, we're going to talk about consumption of vanadium. Here is a chart that shows the consumption of vanadium by application. And what you see here is that the two large slices of that pie are steel applications, different types of steel, but they're both steel applications. So roughly 90% of the vanadium consumed in the world goes into the steel industry. We see a variety of other applications, chemicals being the next biggest application at this point. And vanadium is used in a variety of oxidation catalyst and chemical applications. We also see vanadium obviously in energy storage at a relatively small piece of the global consumption in 2021. The titanium industry has been flat on its back due to COVID, and normally we would see that share of the market going into the titanium alloy industry at 3 or 4% of the total, but it's suppressed due to the state of the market right now. Next slide, please. Look at consumption of vanadium by country. What this chart will show you is that the vanadium consumption as a percentage of total for each country is very similar to that country's steel production, given that 90% of the vanadium is going into steel. So China, Europe, and North America are the predominant consumers of vanadium, with some of the Asian companies being next. You'll note I call out energy storage separately here. As we put this data together, we kind of look at vanadium consumption on a regional basis, and then we overlay energy storage on top of that due to the great uncertainty as to where we really want to say this vanadium is being, quote, consumed in energy storage. Next slide, please. So here's a snapshot in history of vanadium consumption by country, and looking at a projection here for the next few years. And again, you can see here the last few years on this chart. The top bar, the brown bar, is our forecast for vanadium demand in energy storage. Next slide. If we look at vanadium demand in terms of new demand from 2020 onwards, this chart gives us an interesting picture. You see the lower level, the blue color here, is increase in vanadium consumption due to changes in steel production. When historically we look at consumption of vanadium, there's really two drivers, two variables that drive that. One is the absolute level of steel produced globally in the world. And the second factor is the specific vanadium consumption rate in steel, the kilos of V consumed per ton of steel produced. And that number basically is a reflection of what percentage of the steel actually contains vanadium. Looking back, the vast majority of the growth in consumption of vanadium has been due to changes in steel production on a global level. Looking forward, we expect steel production in China and the rest of the world to be somewhat flat. We've seen in the last 15 years very high growth rates, primarily driven by China. And looking forward, the forecast suggests that the growth in actual steel production is going to flatten out. So we won't see tremendous growth in vanadium consumption from increased steel production, but we do see accelerating increase in specific vanadium consumption levels. And that's really an economic decision. Putting a little bit of vanadium, typically half a kilo of vanadium, in a ton of steel, and increasing the yield strength 30 or 40 or 50 or sometimes 100% is hugely valuable from an economic standpoint. Steel is really the backbone of infrastructure that's required to industrialize developing countries to create economic opportunity. And to the extent you can produce that infrastructure with lower cost, it's incredibly important. And so by adding just a small amount of vanadium, increasing the cost of the steel very slightly, we can see a big impact on the consumption of raw materials, consumption of energy, generation of pollution in the steelmaking segment that is there to help us create economic opportunity in the third world. So that growing specific consumption rate is going to become more and more important. We see that rate increasing pretty much every year, and we think that rate of change will accelerate going forward due to the economic drivers. And then on top, we see our forecast for vanadium going into energy storage. And as you can see, by the time we get out to 2025, our projection is that the growth in consumption from 2020 will be fairly dispersed between these three factors, but energy storage does seem to be the biggest opportunity. Next slide, please. So we just stripped off the consumption and energy storage from that previous chart to show here. Our assumption here is following a number of forecasts at grid level energy storage on a global basis, and making an assumption that about 9% of that demand is met by vanadium redox flow batteries. I think there's plenty of room for argument on these forecasts, but this is the forecast that we've chosen. Next slide, please. All right, we're going to move on to production here. Next, please. This is a line that shows a historical trend in terms of vanadium production. You see a fairly steady climb from 2001 up through 2021. Our forecasts looking forward are that we expect to see relatively strong growth in demand for vanadium. And as a result, we expect to see the supply of vanadium growing. So we're showing here an increase in supply from about 116,000 metric tons of pure vanadium in 2021 up to 154,000 metric tons of vanadium in 2025. And the next slide will show us how we suggest we're getting there. The majority of this increase will come from existing capacity that's out there. If you look at this chart, you'll see the blue bar on the left-hand side, China slag-based. There's actually a lot of capacity for the Chinese steel mills to increase vanadium slag production and therefore to increase vanadium production. There's a couple of very large blast furnaces that have had trouble getting up and running over the last few years. And we're projecting those blast furnaces will get up and running and generate a significant amount of vanadium. There's also a lot of idle capacity in what we call the Chinese stone coal. This is primary vanadium ore. It's really a carbonaceous shale material. It's a very different process with some environmental impacts and cost impacts, but that's typically been the swing capacity that's out there in the market. And when demand pushes supply, we see these guys typically coming back on. We'll see some ongoing expansion in Brazil and South Africa from primary mines. And we also see a lot of secondary production, that is vanadium production from ashes and residues generated from either refining or burning vanadium-bearing oils. We're going to see a surge in the availability of these materials as a result of a change in the International Maritime Organization specifications for sulfur in bunker fuel. Previously, bunker fuel was simply the bottoms coming out of the refinery, blended together and burned in seagoing vessels. Today, the new standard requires sulfur levels to be about an order of magnitude below what you typically see. And what that means is these heavy bottoms are going to have to go over a catalyst and be cracked to remove that sulfur before this material can be burned as bunker fuel. And what that means is in a couple of years, we're going to start to see significant amounts of vanadium-bearing spent catalysts show up on the market. And you'll see in this space, a number of companies having announced plans to build facilities in in the Middle East and in China to recover vanadium from those sources. So we do think we're going to see quite a bit of new production from secondary sources coming online relatively quickly. Doesn't take a huge amount of time. We don't have to develop a mine, and the capital is significant, but it's not as intense as a primary mine. The other additional production that we're showing here is the primary production in Brazil, or I'm sorry, in Australia. We are basically suggesting, and we can go to the next slide, that in our projection, we're showing that possibly the Windermere operation will come back into play to provide some additional material. And again, here we see the additional secondary material that's forecast to show up in the market. Next slide, please. All right, so let's roll up production and consumption and look at these two together. And if you look at this chart, the gray area is production, current production that we're seeing as of 2020. The orange area is this projected increase from existing sources. The green area is new sources. Again, some of the perhaps Windermere, perhaps somebody else, and the secondary sources coming online. And then you see the blue line, which is the projected demand. And there's a bit of a gap there. If we go to the next slide, we'll see that that gap is really a small gap considering the level of consumption, and clearly is within the confines of the accuracy of these projections. Next slide, please. I want to make the point that there are dozens of potential new vanadium mines on the drawing boards. Some of these have been promoted for many, many years. Some of them are relatively new. This list is by no means a complete compendium. It's probably covers half of the projects that are out there right now. And the point here is to demonstrate that there are a lot of projects out there, people looking at vanadium. It's a matter of capital flowing to these projects to get vanadium out of the ground. Next slide, please. Chinese rebar production is very important because more than half of vanadium consumption in the world goes into Chinese rebar. In this chart, we can see the declining rebar production in 2021, which really has been declining since May and drops significantly in December, as per the green line here. Next slide, please. We look at annual production of rebar in China. We can see that it peaked out in 2019 and 2020 at about 243 million tons of rebar a year. 2021, we've seen that drop somewhat significantly. The orange line is a proxy for how much vanadium has been consumed in that rebar. So you can see from 2020 to 2021, the declining rebar production has had an impact on vanadium consumption in China, particularly in the second half of the year. Apologize for the spelling error on the title of this slide. Next slide, please. Here we're looking at weekly rebar production data. And you see this drop in production that's really occurred in the second half of last year. And that is concerning. Typically, there's a seasonal effect we see in January and February, rebar production kind of bottoming out in the cycle. But here we see rebar production reaching a pretty low level as of the end of 2021. The next slide kind of drills down on this and looks at the more recent data. And I guess the encouraging part of this picture is that we did see at the end of December a slight uptick in weekly rebar production. So we'll keep our eyes on this number. This is incredibly important in terms of vanadium consumption and determining which way this market's going to go. The other important factor we look at is Chinese exports. And to the extent Chinese exports begin to go down, we'll see some tightness in the market. This slide here really is a measure of profitability in the rebar mills in China. And I think what this shows us is we're in an environment where there's very high profitability for the steel mills to make rebar, and that's an encouraging sign as well. Next slide, please. Looking at rebar, how much vanadium is going to go into rebar going forward. This is a chart from our friends at the China Iron and Steel Research Institute. And this chart was put together in 2020. And if we look at 2021, we're really more or less on that green line scenario in terms of vanadium consumption. So we do expect to see vanadium consumption in Chinese rebar continue to increase, even if the absolute level of rebar production remains stable. Next slide, please. This is another slide from our colleagues in China, which is quite interesting. The new rebar standard in China went into effect in November of 2018. And as typically, it takes some time for the new standards to be fully adopted in China. There are, in the past, we saw people producing high-strength rebar using quench and temper methods, which give you higher strength, but the ductility of the steel is not adequate to absorb the energy when we have seismic activity, and that's when we have catastrophic failure of rebar and buildings collapsing. And the reason the Chinese revised the rebar specification was to plug the loopholes that some of these people were going through, including using these quench and tempered steels. And you can see as time's gone on here, the amount of steel that's substandard, not actually beating the yield strength and elongation standards, has decreased, but we still have about 30% of the steel out there that's not meeting the specs, and most likely that's a result of not putting vanadium in that steel. So this chart just kind of shows there is some headspace in terms of vanadium consumption in rebar, even if the rebar production levels remain stable or below historical levels. Next slide, please. Now I'm going to give you a quick advertisement on our company, US Vanadium. Next slide. This plant was built by Union Carbide in 1966 to process a vanadiferous clay deposit that was in the area. In 1986, Union Carbide spun this business off, and Stratcor, or Strategic Minerals Corporation, was formed. In 2006, Everaz Group acquired Strategic Minerals Corporation and Stratcor. And finally, in 2019, our group, US Vanadium, acquired 100% of the shares of Everaz Stratcor and the Hot Springs, Arkansas vanadium production facility. Next slide, please. This is just a snapshot of some of the products we produce in Hot Springs. And Hot Springs, we're unique in that we only produce high purity vanadium oxides and downstream chemicals. We don't really participate in the ferrovanadium market. You see that product on the far right. That's really a commodity market, and our business is taking our very high purity oxides, which are a function of the technology in our plant, and moving those into the markets that require those high purity materials, typically chemical applications, titanium applications, and now energy storage applications. So we'll produce very high purity V2O5 and V2O3. Next slide. And we can sell those products, or we can convert them into downstream products. And you see a number of vanadium chemicals here with a variety of applications in different fields. And of course, the electrolyte on the far side. Next slide, please. It's a snapshot of where the Hot Springs business is and where we are intending to go. Basically, we're trying to bring this business back to where it was 15 years ago in terms of market share. We've got a good group of people in Hot Springs and a good facility. Again, we think we're producing very, very high purity vanadium products, and we're working really hard to get our market shares back. Next slide, please. And recently, we've announced a expansion of our Electrolyte production, we are producing electrolyte today. We have a capacity to produce about 4 million liters of electrolyte per year. The quality of the electrolyte is extremely high given the high purity oxides that we produce. And we are in a position to produce electrolyte to just about any molarity that people are interested in. On top of that, we secured a long-term agreement for raw materials to feed the plant, and we've acquired a second facility down the road that gives us internal capacity to grind and roast our raw materials. This is a snapshot of the Benton, Arkansas grinding and roasting facility, and the last slide here is an aerial shot of the Hot Springs, Arkansas plant. So yeah, US Vanadium's very, very interested in this business. We've been following this battery since 1990. We do see perhaps the confluence here of the maturation of this technology coinciding with the growth of a real market for long duration storage at the grid level, creating a great opportunity here. And we look forward to supporting the industry. And that's all I have, John.
Great, Terry, thank you very much. We've got a couple minutes here before we move on to our last presentations. We have a half hour left today, but I think we have time for a couple of questions. So Terry, I'm going to read you one from the chat from Vince. Can you tell us about the availability or not of high purity vanadium products suitable for use in making electrolyte versus steel market feedstocks? I know you mentioned that for US Vanadium, but maybe on a more global basis, you could talk about high purity versus steel market feedstock.
Yeah, so given the fact that 90% of the vanadium in the world goes into the steel industry, where we're adding a very small amount of vanadium to the steel, what that means is that the quality of the vanadium consumed by the steel industry really is a secondary issue. The impurities that might come in the vanadium can really not even be measured in the steel when you're putting a half a kilo of vanadium in each ton of steel. So for that reason, the majority of the vanadium production capacity is set up and designed to produce a commodity grade material at the lowest possible cost. That commodity grade material is a fused flake, 98% pure V2O5 product. That's the standard product. If you look at any published prices, it's based on that commodity product. When you talk about electrolyte, of course, every battery company has a different specification, but we can say very generally that the requirement for the electrolyte is fairly severe. The allowable levels of impurities, and we're talking about, I don't know, half the periodic table here, are very low. In some cases, single digit parts per million or less. And so the quality is important. And so this is a situation where you see the chemical industry, the titanium industry, and the energy storage industries really have very different needs for vanadium from a quality standpoint. And there's not that many producers in the world that are set up to produce very high purity oxides that can be used in electrolytes.
Great, thank you, Terry. There's one more here that's specific to you, and then maybe we'll ask any of the other panelists to answer the other question. But the one for you, Terry, how do you translate vanadium consumption in metric tons into energy in kilowatts per hour?
Well, I will say that we consume about 5.5 metric tons of vanadium for every megawatt hour, or 5.5 kilos of vanadium per kilowatt hour. Some of the battery guys may have slightly different numbers depending on the utilization rate, but so we're talking about 5.5 pounds of pure V, or 5.5 kilos of pure V, or about 22 pounds of V2O5 for each kilowatt hour.
Great, thanks, Terry. All right, there is one more question in the chat. I'll mention this here. Here's another one actually for you, Terry. What are the main vanadium sources? Is mining still the most economical way to get pure vanadium, or are other process methods coming to market?
So today, about 70% of the vanadium is produced from slags, vanadium-bearing slags generated by steel mills in Hebei and Sichuan provinces in China and in the Ural Mountain region of Russia, as well as one very small mill in New Zealand. All of these mills process a vanadium-bearing magnetite to make steel. And in the steel making process, they'll drive the vanadium into the slag. They'll generate a slag that's anywhere from 14 to 24% V2O5 content. And that is the source of the majority of the world's vanadium production today. About 20% of supply comes from primary mines, and there's very few of these around. We have the Brazilian mine, the Largo mine. We have the Rovan mine, controlled by Glencore in South Africa, and we have the Bushveld Vametco mine. So these three mines supply about 20% of the world's vanadium, and then about 10% comes from secondary sources similar to what we'll process here in Hot Springs, Arkansas. So the cost of production of vanadium is going to be different based on these different scenarios. And it's really becomes a somewhat detailed discussion. It's hard to, I think if you look at the picture, probably production of vanadium in Russia is the lowest cost in the world, given the fact that the ruble has devalued massively over the last 15 years. But typically you're going to see some of the very, very large generators of vanadium from steel making near the bottom of the cost curve. And then you'll see the primary mines sprinkled in there and the secondary producers somewhere from the middle of that cost curve going up.
Great, thank you, Terry. All right, there's still one more Q&A that I'm going to leave for you, Terry, or others of our panelists to answer in writing, because we need to move on. So thank you very much, Terry. Great presentation. Appreciate it. We've got about